The timing for this particular innovation was perfect because medical research was poised on the brink of a new era of discovery, and they needed new tools, and we were there with tools to provide imaging to help facilitate these activities.
At the time of Dr. Foster's realization, bioresearchers were gearing up for a new wave of genetic research. Lab mice are the ideal models for medical research, and Dr. Foster recognized a new imaging device was needed that could see inside the living mouse to microscopic detail. He developed a new tool now used in research labs around the world. It spawned a business that's doubled each year and generated tens of millions of dollars in revenue. Dr. Stuart Foster, recipient of the $25,000 Award of Distinction.
The classic way to do experiments with mice is to start with a large number of mice and follow them over time at regular intervals, sacrificing the mice, cutting them up and looking at them under a microscope. It's a bad way of doing an experiment because, first of all, you're killing the mouse. That means you're killing all the normal physiology inside the mouse at the same time, and you're looking at a few dead sections of tissue. So what my innovation does is give the researcher the ability to follow mice over time, doing imaging non-invasively, and thereby making quantitative measurements of the tissues and the disease and whatever's going on at multiple time points without sacrificing the mouse. The innovation is actually a new imaging device, and like many innovations, it's actually comprised of many smaller components, and the key breakthrough in this particular device was a way to harness ultrasonic energy to make images with microscopic detail, and brings it to the point where you can resolve structures that are smaller than a human hair. The kernel of the innovation in this particular apparatus is the transducer, and that's a device that transmits and receives the ultrasound. So let's go have a look. The critical component of this system, and the part that holds most of the innovative components, is this little thing over here called the scan head. And this device is what actually transmits and receives ultrasound from the mouse that we're trying to study. And essentially it's, you can view it as a flashlight for ultrasound. And it creates a very small ultrasound beam with a width smaller than a human hair that essentially propagates out from this transducer into the tissue and receives the echoes back from the tissue to create the image, and creates images anywhere between 30 frames per second up to 300 frames per second. Well, if I wanted to do a cardiac study on a mouse, I would take my mouse, I'd place it on a comfortable stage here in which the paws are contacting these electrodes. That gives us a ECG monitor for the mouse. And then the mouse's nose goes in this little opening, and that's an anesthetic gas that keeps the mouse calm and comfortable. And when I want to image, I have my scan head here. I lower that scan head onto the mouse, or close to the mouse, through usually some kind of gel, and then we proceed with the imaging procedure. And in this case, we're seeing the mouse's skin surface, and this is now depth into the mouse. These are in millimeters, so this is roughly about 5 millimeters. You can see the mouse's heart rhythmically contracting, and you can see the heart muscle tissue as a bright kind of donut. You have to see the living microcirculation, and that's what's important. It's exactly like giving researchers a new set of eyes that they had not previously been able to see their biological experiments with. So the majority of research being done with micro-ultrasound is in the field of cancer research, cardiovascular disease, developmental biology, and to a certain extent in stem cell therapies. But the major advantage of the imaging technology is the speed with which it delivers images and the functional information that it brings back from the tissues that are being imaged. Most of the major drug companies have 2 or 3 systems that they use in various experiments. And their angle, of course, is to speed up the development of new drugs for these diseases. It's very special to be singled out like this, and to be in the 25th year is also special because that's obviously a landmark year, and I think that this sort of award will only serve to help others develop their ideas and perhaps in the future become successful in this sort of thing. Think big and dig in and get the job done.